Good morning, ladies and gentlemen. Fellow viewers, this is Prof 1 Tutorials. My name is Alfred Amprofi, and we are here again to look at limits of a function. Limits of a function. When we talk about limits of a function, this is when a particular function given its behavior changes as x also changes. So over here, as x increases, you realize that the behavior of f of x also changes, either in the increasing or decreasing direction. As well as x also decreases, the behavior of the function f of x also increases or decreases. So let's have a short note. For a given function f of x, as x approaches a particular number, let's say a, it is written as x approaches a. So as x approaches a, this is how we write it. So we can say that the behavior of f of x increases or decreases as the value of x changes. All right, so now let's look at an example. For example, giving f of x to be equal to 3x plus 2 around x is equal to 4. So as the function f of x approaches 4 or goes away from 4, we are going to look at the behavior of the function f of x. So let's have a table. So we have x here, we have f of x here. So now the value is 4. That's the value of x. So I'm going to start from 3.7, 3.8, 3.9. We have 4, 4.1, 4.2, 4.3. Now let me add 4.4. So we are going to make substitution. So for f of 3.7, we are going to have 3 multiplying 3.7 plus 2. So when 3 multiplies 3.7, we are going to have 11.1. So we have 11.1 plus 2, and it is giving us 13.1. So we have 13.1 here. Now let's make substitution of 3.8. So we have 3 multiplying 3.8 plus 2. And when 3 multiplies 3.8, we are going to have 11.4. So we have 11.4 plus 2, and we are getting 13.4. So we have 13.4. Now when we substitute 3.9, so we have f of 3.9, we are going to have 3 multiplying 3.9 plus 2. And 3 times 3.9, we are going to have 11.7. So we have 11.7 plus 2. It is also giving us 13.7. When I substitute 4, we have 3 multiplying 4 plus 2. So 4 times 3, we have 12 plus 2, and it is giving us 14. When I substitute 4.1 in the function, so let me come to this side. We have f of 4.1, we have 3 multiplying 4.1 plus 2. And we are going to have 12.3 plus 2. We are going to get 14.3. So we have 14.3. When we substitute 4.2 in the function, 3 multiplying 4.2 plus 2, and we have 12.6 plus 2, we are going to get 14.6. So we have 14.6 here. When we have f of 4.3, we have 3 multiplying 4.3 plus 2. Then we are going to get 12.9 plus 2. We have 14.9. 14.9. Then the last one is f of 4.4, which is equal to 3 multiplying 4.4 plus 2. So 4 times 4.4, we have 13.2 plus 2. When we add, we are getting 15.2. So we have 15.2 here. So you realize that as we make substitution of each of the value of x, f of x keeps on changing. So now let's see. We were trying to find around 4. So as we decrease from 4, we have 3.1, we had 13.7, 3.8, 13.4, 3.7, 13.1 in that order. And as we increases the value of x, from 4 we have 4.1, we had 14.3, 4.2, 14.6, 4.3, 14.9, 4.4, we had 15.2. So basically when you talk about limit is when the value of x changes as the behavior of f of x or the function also changes. Either it increases or decreases. Viewers, limit plays a very key role when it comes to calculus. So now we are going to look at some of the forms of limit and how it is done. So quickly, let's get started. So the first one we are going to look at is limit of a constant. Limit of a constant. So where k is a constant. So I am using k to represent the constant. Now when you have limit as x approaches a of a constant k, then you are still getting k, because we don't have any value of x in this expression. In that case, we can't substitute a here, so we are still going to get k. For example, limit as x approaches 2 of 3, we are still going to get 3, because there is nothing of x to substitute the 2 in here. So here we are still going to get 3 to be the final answer. Let's get the second one. Limit of a function x. So we have limit as x approaches a of x, then we are going to get a. because we are only substituting the value of a at where we see x. So when I put a here, I am still going to get a. For example, we have limit as x approaches -1 of x. Then when I put -1 here, I am still getting -1 because the value of x is -1. Let's get the next one. Limit of a function x exponent k. So we have limit as x approaches a, we have x power k. So because the x is carrying an exponent, I'll just substitute a in the function. Then we have a exponent k. So let's pick an example. So we have limit as x approaches 3 of x power 3. Then we are going to get, now it is approaching 3, so I'll put 3 here. So I have 3 exponent 3, and that will give me 27 to be the value of, or that will be the final answer. The fourth one is limit of a function kx. So here a constant multiplying the value of x. So when you have limit as x approaches a, kx, at this point I can substitute the a at where I see the x. So I'm going to have ka because I am substituting a in place of x. So let's have an example. So we have limit as x approaches -2. Then I have, let's say, 3x. So at this point, I'll just substitute the -2 at where I see x. So I have 3 multiplying -2, and the answer is going to be -6. Now the next one is going to be limit of the function f of x multiplying g of x. The fifth one is limit of a function f of x multiplying g of x. So we have limit as x approaches a, f of x dot g of x. Over here we are going to expand. So we have limit as x approaches a, f of x. So the limit will take the f of x dot, then this limit will also take the g of x. So we have limit as x approaches a, g of x. So at this point we are going to substitute a in each of the function. So we have f of a dot g of a. So now let's look at an example. So for example, limit as x approaches -4, then in a function we have x squared plus 2 and then 3x minus 1. So these are the two functions we have. So at this point we are going to have limit as x approaches -4, we pick the first function, and that is going to be x squared plus 2 multiplying limit as x approaches -4. Again from here it will now take the second bracket. So we have bracket open, 3x minus 1. 3x minus 1. Now in this case we will now substitute -4 at where we see x. So we have -4 squared plus 2 multiplying Then I will substitute -4 here. So I have 3 into bracket -4 minus 1. At this point, -4 squared, we have 16 plus 2. Still within the bracket, then we have -12 minus 1. So over here, 16 plus 2, we have 18. Multiplying -12 minus 1, we have minus 13. Now, we are going to multiply the 18 and then the -13. And when we multiply them, we are going to get -234. -234 to be the answer as the final answer. The next one is going to be limit of rational functions. So let's say we have f of x is equal to g of x over h of x. So this is a rational function. We all know that rational functions can be expressed in the form of a fraction where h of x is not equal to 0. Where h of x is not equal to 0. So in this case, if you have limit as x approaches a of f of x, then we are going to have limit as x approaches a g of x all over limit as x approaches a, then h of x. So here the limit is going to be applied to each function. So quickly, let's look at some few examples. So for example, limit as x approaches -1, in a big bracket we have x squared minus 1 all over x plus 1. Now at this point, if you substitute the -1 directly, this is what it's going to be. So when you substitute -1 here, you have -1 squared minus 1 all over -1 plus 1. And we all know that -1 squared, we are going to get +1 minus 1 over -1 plus 1, we are going to have 0. And here we are going to get 0 over 0. And 0 over 0 is undefined. It does not exist anytime the denominator is 0. In that case, from the numerator, we are going to factorize. So limit as x approaches -1. So x squared minus 1 is the same as x squared minus 1 squared all over x plus 1. We still have limit as x approaches -1. We have not yet applied the limit, so we need to repeat it. Now this is difference of two squares. The minus here means difference, x squared 1 squared of 2 squared. So it's the same as x minus 1 multiplying x plus 1 all over x plus 1. So from here, x plus 1 can take off x plus 1. Then it will be left with the x have limit as x approaches -1 into bracket x minus 1. In this case, we can substitute the -1 here. So we have -1 minus 1. The -1 minus 1, we have -2. We have -2 to be the final answer. Now let's look at another example. We have limit as x approaches +2 x squared minus 4 all over x minus 2. Over here, when we substitute 2 here, we are going to have 2 squared minus 4 over 2 minus 2. And we all know that 2 squared is 4 minus 4 over 2 minus 2. Then basically, we are going to have 0 over 0. So in this case, we need to factorize. So limit as x approaches 2, x squared minus 4. Now we know that 4 is a perfect squared and is the same as 2 squared all over x minus 2. So we still have limit as x approaches 2. This is also difference of 2 squares. So we have x minus 2 multiplying x plus 2 all over x minus 2. So this will take off this. So it is going to be left with limit as x approaches 2, bracket open, x plus 2. So at this point, we can substitute the 2 here. So to have 2 plus 2, and the answer is 4. Now we are going to move on to another thing, which is limits involving infinity. Limits involving infinity. Seventh one, limit involving infinity. So now let's have a short note. Limit of a function, limit of a function as x approaches infinity is written as x with an arrow, then you bring the infinity sign. This is the infinity sign, and that is as x approaches infinity. Now let's have some few examples. We are going to have limit as x approaches infinity. So for example, limit as x approaches infinity, then we have a big bracket, 2x cubed minus 7x plus 3 all over x cubed plus 2. X cubed plus 2. Now when we are solving questions under infinity, we can't substitute the infinity directly in the function because infinity is a very large number. So when you substitute at the end of the day, you are going to get everything to be infinity over infinity, and that is going to be infinity. Infinity over infinity is still a large number. Okay, so we are not going to substitute the infinity directly. So when a function like this is given, all that we are going to do is to divide each by the highest exponent of x. So here the highest exponent of x is x cubed. So we are going to have 2x cubed over x cubed minus 7x over x cubed plus 3 over x cubed all over x cubed over x cubed plus 2 over x cubed. Now from here we can try and then break it down. So this can take off this. One of this can also reduce one of this. We have x squared. This can also take off this. So at the end of the day, we are going to have 2 minus 7 over x squared plus 3 over x cubed all over 1 plus 2 over x cubed. So we are still looking at limits. Now, after reducing the values of x, then we can now substitute the infinity. So in substitution, we are going to have 2 minus 7 over infinity squared plus 2 over infinity cube all over 1 plus 2 over infinity cube. Now, when we divide 7 over infinity, it will be approaching 0 because you are dividing by a very large number. So if we have a very short recap, if you have, let's say 1 over 10, we have 0 0.1, 1 over 1000, we have 0.001. So you see that as we are dividing by a very large number, it will be approaching 0. So in that case, we are going to have 2 minus everything here will move 0 plus everything here will move 0 all over 1 plus everything here will also move 0, because when you are dividing by an infinity, we are going to get a very low number which will be approaching 0. Okay, now let's get a final answer. So in this case, 2 minus 0 plus 0, we still have 2 over 1 plus 0, we still have 1. Then the answer is going to be 2. The answer is going to be 2. Let's get a second example. We have limit as x approaches infinity. Then we have x squared minus 1 we have x squared minus 1 all over 2x squared plus 1. So just as we did the first example, we are going to divide each by the highest exponent of x. So we have limit as x approaches infinity. So we have x squared over x squared minus 1 over x squared all over 2x squared over x squared plus 1 over x squared. So from here, x squared can cancel x squared. X squared here can also cancel x squared. Then if that's the case, we have limit as x approaches infinity. In a bracket, we have 1 minus 1 over x squared all over 2 plus 1 over x squared. Now, after reducing them, we can make substitution of the infinity. So we have 1 minus 1 over infinity squared all over 2 plus 1 over infinity squared. Because we are dividing by a very large number, it will be approaching 0 all over 2 plus, here we also have 0. Then the final answer is going to be 1 over 2 to be the final answer. So viewers, this is all about limits. We are going to have some aspects of limits in our next video. So viewers, keep on watching. Don't forget to subscribe if you have not yet subscribed. Share, like, and you can share your comments as well. Stay tuned. Bye bye.